This is Alden representing the team Chain of Hashes. Our problem statement title is Online Certificate Generation and Validation Using Blockchain. Currently, large number of training programs is organized and certificates are provided. There is no mechanism to validate all these digital certificates. Well, a digital certificate typically looks like this. It has a name field mentioning the owner of the certificate, the event type, the date the certificate is issued on, and in some cases it also has a digital ID. There's a problem in following this paradigm. Anyone with malicious intent can easily modify these names and provide it as a legitimate certificate. So how can we prevent this? So far, the certificate credentials are stored on third-party websites, and we have to trust them with the credentials they show up to us. So how can we move the credentials from third-party websites and store it in our blockchain? Let's have a look. So here I have extracted the name, event, organization. So these are the attributes and map them with the respective values. Some mining is a process that we do whenever a new certificate is issued. This makes sure that the certificate is registered onto the blockchain network. The data stored in a blockchain is immutable, tamper-proof, transparent, and even better, decentralized. Eliminating the trust factor, we don't have to trust a central third party. If I try to change a single letter, you can see that the entire block turns red, meaning the block is invalid. Let's add a few more certificates into our blockchain with basic credentials like name, event, organizations, along with an Ethereum address which is a unique web ID provided in Web 3.2. So the data is added and the mining process is done during the issuing of the certificate. Now that we have written our credentials into the distributed ledger, if I try to dump one certificate's data, you can see the entire chain will be rendered invalid. Here I am editing the first block. You can see all the blocks in the blockchain turns red, meaning the entire blockchain is invalidated due to a single change in the genesis block. Now that we have written our credentials to the distributed ledger, that is blockchain, it remains decentralized, meaning everyone knows the true credentials issued for a certificate. When a validator has to validate a certificate, he simply collects the data from the given certificate and matches it with the one that exists on the blockchain. If they match, it is an authentic certificate. If they don't, it is a tampered one. While this mediocre solution is perfect for educational certificates, using this system to store and validate highly sensitive certificates poses a security threat. But the sensitive information contained in the certificate is distributed to each and everyone in the network. To address that, we came up with an even better solution. We take the certificate, extract the sensitive details, and use a one-way hashing algorithm like SIH1365 and get an output hash. The hash is fixed length. We then store the hash itself into the blockchain. So the blockchain will not know the data that is stored inside, but it always has the integrity of the data. You can see if I try to tamper the data here, the entire hash changes, meaning the output hash is always unique for the input. Unlike the first solution where we store the credentials itself, here we store the hash values of the credentials into the blockchain. Later, when the certificate needs to be validated, a similar hash is generated with the given data and then it is compared with the hash that is already stored onto the blockchain. If both the hashes match, it means the certificate is valid and the data contained in the certificate is the one that is provided during the time of issuance. If the hash doesn't match, the certificate is tampered and the certificate is invalid. This mechanism is unbreakable, meaning only authentic certificates are rendered valid. This is the 100% secure way to store and validate any type of digital certificates. To automate all these works, we have done a project. Let's have a look into that. In our project, we can sign up as a user with either of these roles. Let me just create two accounts, one as a student here and one as a issuer here. Here, let me just quickly log in into the user ID as an issuer. It says login successful, and if I navigate to the certificate upload page, I can add the user ID here and select a random date here and name the event as a workshop event. And if I click register, as a new certificate will be issued into the blockchain network and it says certificate uploaded successfully. So if now I quickly log in back as a student here, I have logged in. So if I navigate into the certificate page as a student, So it lists all the certificates that has been generated for me, and this is all the process we have just explained is done automatically here. You can see the event name is workshop event, the certificate ID, the unique Ethereum address that belongs to the user, the issuer name, the date, the organization name, and even the certificate holder. So whenever a validator has to validate this certificate, he simply takes all these details from this and use a one-way hashing algorithm like SIH1365 and gets an output hash and verify the hash itself to the one that is present in the blockchain. If both the hash matches, the certificate is valid. The validation part can also be automated, and it is yet to be implemented in our project. Our project is 90% complete, and it provides a 100% secure way to create and validate digital certificates. Thank you.